Homework time! Homework time is here again. Happy days are here again. Lesson 6 of Module 3. Let's start by jotting names down at the top of the paper. I'll write my name and you write yours. And let's go ahead and write today's date. I will write the word today while you write the actual date, where, and when you are. Our directions here for number 1, or the first few here, are represent the following problem by drawing this in the place value chart. Okay, so to solve 30 by 60, 30 times 60, we want to think 3 tens times 6 times 10. See, so the 60 is broken out into 6 times 10, decomposed in this way, and then regrouped using the distributive property with the 3 tens times 6. We could also think of it then as 30 times 6 times 10, that's our 60, right? 30 times 60, which is the original question we're presented with. So to draw this out, we're going to draw 3 tens times 6 times 10. And here's what it looks like. And with a lot of these, we'll draw our 3 tens. It's not so much that the math is difficult. I think sometimes, and especially for us who are taught differently, the question is, well, what does Eureka Math want from me here? I can do the math, but what am I supposed to write on this place value chart? And that's why I'm here. So there's 3 tens, right? And let me circle them up. I'm going to do 3 tens times 6 and then multiply that by 10. So there's one set of 3 tens. So here's a second, 2, 3. Circle them up. There we go. Set of 3 tens. And then 1, 2, 3. That's our third set of 3 tens. 1, 2, and 3. A fourth set of 3 tens. 1, 2, 3. A fifth set of 3 tens. And 1, 2, 3. A sixth set of 3 tens. And so if you look, it says 3 tens times 6, right? We have 3 tens 6 times. So there's the 3 tens times 6. Now to show this all times 10, the next step there, you simply ride the times 10 slide. So you draw the arrow to the next place, because each place value is 10 times greater than the one preceding it. So times 10, and guess what we draw here? Yes, the exact same thing, but not just for the sake of drawing the same thing twice, but just to demonstrate that we understand what we're doing. Look, those 3 tens right there times 10 are 300s. And we have to do out all 6. So there's the second set, 1, 2, 3, and the third set, 1, 2, 3, the fourth set, and 1, 2, 3, the fifth set, and lastly 1, 2, 3, the sixth set. Okay, so now if you look at it, what do we have? Well, we have 3, 6, 9, 12, 15, 1800s. 1800s, which we'd write in standard form as 1,800. And to do it this way, to do the 6 times 10 first, then times 30, what would we get as a product there? Yes, the exact same thing, because that's a distributive property in action. So it would still be 1,800, which means that ultimately our original question, 30 times 60 equals, yes, one more time, 1,800, 1,800. And you say, why do I have to draw these twice and write the answer, same answer 3 times? So you understand how the math works. So let's go a little deeper on to number 2. All right, and here we have numbers 2 and 3. In both cases, we want to draw an area model to represent some multiplication. And you see here, this 30 times 60, of course, is the same one we did up in number 1. Now we'll do it a different way. So these area models might seem a little complicated at first, but they're actually quite simple. So we're going to draw this side to be our 30. And then our 60 side should be about twice as long, right? Because 30 is half of 60. And now I will go ahead and label the sides. And this one I'm going to label as 30, and I want to keep in mind that that is equal to 3 tens. Right, and that's what I drew up in the place value chart. And then our width here, again, same thing. This is my 60 side, and I want to keep in mind that this is 6 tens. Now, what does this area model show? It shows 30 times 60, right? 30 times 60. And which I could also write as, well, I wrote 3 tens and 6 tens, so I could write this as 3 tens times 6 tens. Now, here's the one little thing you really need to learn in this entire lesson, which is tens times tens is hundreds. That's it. That's the crux of this lesson right there. If you're multiplying 10 times 10, it's 100. So tens times tens will be hundreds, okay? And if you can keep that little factoid and practice and skill straight in your head, you'll do fine in all this. And it makes the multiplication so much easier. Look, 3 tens times 6 tens, well, I know it's going to be a certain number of hundreds. How many hundreds? Well, 3 times 6 is 18. So it is 18 hundreds. And that, my little friends, is what they're looking for down here in this blank. 3 tens times 6 tens is 18 hundreds. And that's it for this one. Look at that. Does that make sense? I hope so. If not, look, we're going to do another one. So draw an area model to represent 20 times 20. Well, we know if it's 20 by 20 in its dimensions, what kind of shape is it? It's square. Talking squarish to ya. Okay, that's a square, believe it or not. It is because I say so. And this side we know is 20, which is 2 tens. And although it's a square, I'm still going to go ahead and label this side just so I'm all clear with myself and anyone else looking at this, that that side is 20, which is equal to 2 tens. And I don't know if I have enough room in here to do all the work, but I will write inside here that this is equal to 20 times 20. You see how this is area? You see why we did perimeter and area at the beginning of this module? Because look, it's an area model. That's why it's called that. That's how you can do multiplication. And so now 20 times 20 is 2 tens times 2 tens. And now when you think about it, 2 tens times 2 tens is going to be a certain number of hundreds. So that's equal to, well, 2 times 2 is 4, easy enough. And we're talking about hundreds. And in case you're wondering, well, I don't see how that works, what you can do is you can think of this as 2 tens is 2 times 10, right? That's 20. And we're multiplying that also by 20 times 2 times 10. And using the associative property, we could say, hey, I could rewrite this as 2 times 2 times 10 times 10 times 10 times 10, which ultimately is 4 times, 10 times 10 times 10 is 100. That's why I say 400s here. So do you see why the answer, even though I'm doing tens times tens, that my answer is going to hundreds? It's because of this right here. This is the explanation of why that happens, why that works. So 2 tens times 2 tens is 4 hundreds. And in this one, they actually ask you to put it in standard form, which we'd already done. 20 times 20 equals 400. We didn't do it up here, but we can add that in. Sure, why not? Just to make sure that we know it's 1,800, that 1800s is 1,800. Well, beauteous. 2 and 3 are done. Let's keep rolling on to number 4, shall we? Yes, we shall. And here in number 4, we're going to put this into more deliberate practice, drawing an area model to represent 40 times 60. And so same idea here. We're going to have a 40 side and then the 60 side. See, that would be about 40, right? They're about equal. And then so a little bit longer will give me 60. You know, roughly proportionate, not exact. There's my area model. This side here, love drawing these brackets, is 40, which I know to be equal to 4 tens. And the longer side, the width here, is 60, which is 6 tens. Lovely. So inside the area model, what I'm solving for here is 40 times 60, which I'm thinking of as 4 tens on the place value chart, right? Times 6 tens. And I know that tens times tens will give me what? Hundreds. So I'm going to write that down, so don't forget that. And I'm doing 4 tens times 6 tens. 4 times 6 is 24. So you see, if you know your basic facts, which I'm assuming you do, this stuff is actually pretty easy. 24 hundredths is what it equals, and 24 hundredths equals, in standard form, think 2, 4, the 4 is in the hundredths place, 0 tens, 0 ones, 2, 4, 0, 0, that'd be 2,400. And that is what we're looking for in the fill in the blanks here. That we have 24 hundredths, which we'd write in standard form as 2,400. Really, that's a 4. Okay. Beauteous! How do you like that? We're blowing through this. Let's move on, shall we? Yes, let's do it. All right, we have new instructions here. Now you see we're taking the next step, taking what we learned at the beginning and really putting it into action. So we will rewrite each equation in unit form and solve. Okay. And you see this is what is meant by rewriting it in unit form. It's basically done for us here. They give us all this space here, but we really won't be needing it. So we'll do the unit form first and then go back for the final solution. 5 tens times 2 tens. Well, we know that tens times tens is hundreds, right? So 5 times 2 is what we're doing. So that is 10. And we're talking about hundreds. It's that simple. Really, 10 hundreds. Now, what's that as? Well, 10 hundreds, 100, 200, 300. Okay, that's 1,000. You got it. See how easy this is? And just on this one, let's break it down so that I know that you know, and you know that I know, and everybody knows you know what you're doing. 5 tens we're thinking of as 5 times 10, right? That's 50. And that's what we're multiplying by 2 tens. That 20 we can think of as 2 times 10. And then we just use the associative property to rearrange our parentheses. So the way we're doing this is saying, well, let's do the 5 times 2 separately, because that's easier. And then multiply that by 10 times 10, because that's way easier than just doing 50 times 20 and staring at it and guessing, or putting in too many or too few zeros. This is a much surer way where you understand what you're doing. So 5 times 2 is 10, and 10 times 10 is 100. And what is 10 hundredths? What is 110 times? We already determined that's 1,000. See, so this is an explanation of why this works. And we won't do it for all 4 of these, but I wanted to do it on the first one, make sure you are all clear on what we're doing and why. It's much more accurate, faster, easier, and demonstrates a greater depth of understanding that you can break it down this way, even just in your head. So in this one, now we'll cruise through these. 3 tens times 5, well, 50 is 5 tens. And how many hundreds will that be? Well, it'll be 3 times 5 hundreds. It will be 3 times 5? 15 hundreds. 15 hundreds in standard form? Right, 1,500. Told you we'll cruise through the rest of these. I'm not going to walk you through every last little step. I'm going to assume you're getting it. So in 60 times 20, that's, well, it's 6 tens times 2 tens. 6 times 2 is 12. Tens times tens is hundreds. So 12 hundreds. And 12 hundreds written in standard form. 1200 is 1,200. You got it. You got the hang of this. In this case, they give us almost everything blank, but we know 40 is 4. That's right, tens. And 70 is, that's right, 7 tens. You know 4 times 7? It's one of those obscure ones. 4 times 7, yes, 28. And tens times tens is hundreds. So 28 hundreds written in standard form. That's right, 2,800. Boy, did we whip through those. So now let's go on to the good part. Well, you guessed it. Now we're going to take everything we've done and put it to use in some real-life word problems. And this one's cool because there's actually, maybe you could turn this into a Broadway smash hit. A song about maybe how many seconds in an hour, how many minutes are in a year sort of thing. You get the reference? Anyway, so there are 60 seconds in a minute, we know that, and 60 minutes in an hour. Okay, we knew that as well. How many seconds are in 1 hour? So seconds in 1 hour. So if you take the number of minutes in an hour, and I'm going to do it out this way so you can see. We're saying there are 60 minutes per hour. And if we wanted to find, we're starting with that, how many minutes in an hour, we're trying to find how many seconds in an hour. If we were to multiply this by, yes, 60 seconds per minute, we would end up with seconds per hour. And I'll put a good old-fashioned question mark. That's what we're trying to find, how many seconds in an hour. And for those of you kind of looking ahead algebraically at this, what we'd end up with is minute seconds per hour minute, and in the old parlance at least, you're dividing minutes by minutes, and so they cancel out, and so that's why you end up with seconds per hour. So that's a little advanced note for you there. So let's draw a little area model to show 60 times 60. And yes, indeed, that's going to be a square, or our nearest approximation of a square. Pythagoras rolls in his grave every time I draw a square. Okay, so this is 60, which I know is 6 tens. And this as well is 60, which I know is 6 tens. Lovely. So that means as an area model, the area of this square is 60 times 60, which we already know is 6 tens times 6 tens. And we know that 6 times 6 is 36, and tens times tens. Remember I said the one thing you definitely want to walk away from this lesson with is tens times tens is, yes, hundreds. And so 36 hundreds written in standard form is, right, 3,600. And so our statement is simply, there are 3,600 seconds in 1 hour. Periodo. And let's go dancing on to number 10. And in number 10, this is another real world example. So even just like I as a teacher, if I'm going to the copier and I try to use it as little as possible, conserve resources, but even still, sometimes you have to. I say, well, this is 20 pages and you have 25 students. You know, is a ream of paper going to be enough, or do I need to bring extra paper? Because you want to be halfway through and the copier starts beeping at you and you got to run all the way back to your classroom to get more paper or something like that. You want to make sure that you have enough paper and yet you don't bring 3 packs and you only needed 1. So this is the kind of math that you actually have to do in real life-io. So let's read it. Number 10. To print a comic book, 50 pieces of paper are needed. How many pieces of paper are needed to print 40 comic books? So you can tell this is multiplication because we're going to do something a certain number of times. So there's our times, right? 50 pieces of paper we're going to print 40 times. So let's draw an area model for that. There's my 40 and my 50 is a little bit longer. And I'll label this side. That's my 40 comic books. And we know that 40 is equal to 4 10s. And up top, my width here is 50 pieces of paper, which is 5 10s. And so the area is length times width. Right, it's 40 times 50. Also known as 4 10s times 5 10s. And so what we're doing is we're going to do, and I'm not writing this step out because we've done it a few times already, but thinking, okay, I'm going to do 4 times 5 and then multiply that by 10 times 10. So 4 times 5 is 20. And 10 times 10s is hundreds. And so to write this out in standard form, 20 hundreds. Now if you wrote 200, you'd say, that's 200. That's not 20 hundreds. And if you went too far and did 20,000 rather, 20,000s, you say, that's 20,000s, not 20 hundreds. So just give yourself that does my answer make sense check. So 20 hundreds we know is going to be 2,000 in standard form. All right, so a simple statement. How many are needed? I'm going to invent a you here. You will need, whoever you are, in the question, not you, but them you. You will need 2,000 pieces of paper, which would be 4 reams, 4 of those little packs. So you have to load up to go to the copier. You'll need 2,000 pieces of paper. Well, look at it. You've done it again. Finished another homework time. So I will see you next time. It is once again homework time.